Hi everybody. So in this video, we're going to look at calculating a probability from a histogram. We'll work through this question and then we'll try an exam style question. If you want to work along with me, you can download a copy of a PDF from my website. I'll leave a link in the description below. So for our first example, we're told that the histogram shows the distribution of masses of 30 students in a class. We've been asked to work out the probability that a student has a mass more than 50 kilograms. So if we begin by saying the mass is m, we want the probability of m being greater than 50 kilograms, okay? And we're told that the total sample is 30 students. So this will be out of 30. So we need to work out the frequency for this bar and for this one. And we know that frequency is the class width multiplied by the frequency density. So between 50 and 55, this will be 5 multiplied by the height of 1. So this will have a frequency of 5. And then between 55 to 70, we've got a width of 15 and a height of 0.2. So this will have a frequency of 15 times 0.2, 3. So the probability of a mass being greater than 50 will be the sum of a 5 and a 3, will be 8 out of 30, and we can simplify that to make 4 out of 15. Okay? So for question B, estimate the probability that a student chosen at random has a mass less than 60 kilograms. So we're looking at the number of people up to this point. And rather than working out each of these individual bars, we could just work out this frequency and take that away from 30. And we can work out this frequency using interpolation. So if we draw our scale, we know the class width of this bar is from 55 to 70. We want to look at the position of a person who weighs 60 kilograms. We know there are 3 people within this bar, and there's 30 overall. So we'll have 27 here and 30 here. And we'll call the person who weighs 60 kilograms X. So using interpolation, X minus 27 as a fraction of 30 take away 27, so 3, will equal this distance, 60 take away 55, as a fraction of 70 take away 55. We'll move this 3 to the right-hand side. We'll get 15 over 15. So X minus 27 will equal 1. Then we'll add the 27 to both sides. So X will equal 28. So if there's 28 people up to this point, we know the probability of a mass being less than 60 will equal 28 out of 30, or 14 out of 15. Okay? Let's try another question. So in this question, we're told that the partially completed histogram and table show the time to the nearest minute that a random sample of patients had to wait to see their doctor. We've been asked to estimate the probability that a patient chosen at random was delayed between 8.5 and 13.5 minutes. So the first thing we need to do is to complete our histogram. Because we've plotted the minutes along the continuous scale and the data is given as discrete values, we've had to use continuity correction, where we're looking at the upper and lower bound of each number. So for instance, this 4, we're looking at the lower bound of 3.5, and this 6, we're looking at the upper bound of 6.5. And we'll say m is for minutes. So you can see that these 6 patients go from 3.5 to 6.5. Like I say, this is because the minutes have been rounded. So this tells us then Now we've got a class width of 3 with 6.5 take away the 3.5 multiplied by the height of 2. This will give us 6 patients. So between 7 to 8, we're actually looking at between 6.5 and equal to 6.5, but less than the 8.5, which we can see in this bar here. So for the 9 minutes, this will be between the 8.5, it can be equal to that, but less than the 9.5. And that would be between this point and this point, which are their class width of 1, and 1 times 9 will give us this number of patients. So we're going to go up to 9 here, okay? And then I should have said here that between the 6.5 and the 8.5, we've got a width of 2, and you can see we've got a height of 7, so this will give us 14 patients. Moving on to the next class, between 10 to 12, we know this will have a width of 3 and a frequency of 24, so our frequency density must be 8. And then between 16 to 20, we're looking at 15.5 and 20.5, so a width of 5, a frequency density of 1, so this will give us a frequency of a number of patients as 5. So now if we go back to the question, we want to estimate the probability that a patient was delayed between 8.5 and 13.5 minutes. Well, between 8.5 and 9.5, we've got 9 patients. Between the 9.5 and the 12.5, we've got the 24 patients. So then we need to look at the frequency of between 12.5 and 13.5. So we're looking at this bar in red. You can see this has a width of 1 and a height of 3. So this will be 3 patients. So the probability that m is less than 13.5, but greater than or equal to 8.5 will be the 9 add the 24 add the 3, so 36. And we can work out the total by adding these together, and we get 67. So this will be our probability. Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.